Let us deal with our new topic, which is remainder theorem. Remainder theorem states that if a polynomial p of x is divided by x minus r, then the remainder is the constant p of r. Let us prove the remainder theorem. Let p of x be the dividend, x minus r the divisor. The remainder when p of x is divided by x minus r, it can be written in the relation p of x over x minus r equals q of x plus r over x minus r. First, we multiply both sides of the equation by x minus r. That's why we have p of x equals x minus r times q of x plus r. We replace x by r, so that we have p of r equals r minus r times q of x plus r. Then we simplify. R minus r is equal to 0 times q of x plus r. 0 times q of x plus r is equal to 0 plus r. That is why p of r is equal to r. Therefore, if p of x is divided by x minus r, the remainder is p of r. That really proves that if a polynomial p of x is divided by x minus r, then the remainder is the constant p of r. There are two ways to find the remainder when p of x is divided by x minus r, and that is using synthetic division or calculating the p of r. Example, let us find the remainder when 6x squared plus 2x plus 1 is to be divided by x plus 3. So the first method is using the remainder theorem. So for this method, we know that the remainder is equal to the value of p of r. So since this is our divisor, it means that we are going to calculate the p of negative 3. So the p of negative 3 then will be substituted to this equation. So we have p of negative 3. So we're going to change all the values of x into this equation. That's why we have 6 times negative 3 squared plus 2 times negative 3 plus 1. Then we simplify the exponent first, which is 6 times 9. 2 times negative 3 is negative 6 plus 1. Then we have 6 times 9 is 54 minus 6 plus 1. 54 minus 6 plus 1 is equal to, what is p of negative 3? Which is 49. So it means that the value of the remainder is 49. Let us try the other method, which is using synthetic division. Since we know that our r here would be negative 3, and then we just arrange this, which is 6, 2, 1. So firstly, we have to bring down 6. 6 times negative 3 is negative 18. So 2 plus negative 18 is negative 16. 16 times negative 3 is, so negative 16 times negative 3, is positive 48. And then we add 1 plus 48 is 49. So we know that the last coefficient here, or the value, represents the remainder. So it means that we got the same answer using both method, which is the remainder theorem and the synthetic division. Let's have this example. Find the remainder if 4x cubed minus 2x squared plus 3x minus 5 is to be divided by x minus 1. So we will be using two methods here, which is the remainder theorem and the synthetic division. So for the remainder theorem, we are going to calculate P of positive 1. Since our divisor is x minus 1. So for here, we're going to substitute all the values of x into positive 1. So that we have 4 times 1 cubed minus 2 times 1 squared plus 3 times 1 minus 5. So, we work on the exponent first. So, we have 4 times 1 minus 2 times what is 1 squared, which is 1, plus 3 times 1, which is 3, minus 5. And then we multiply. 4 times 1 is 4, minus 2 times 1 is 2, plus 3, minus 5. So, my way of calculating this is combining all the positive first, which is 4 plus 3, which is 7. And then I'll be combining the negative, negative 2 and negative 5, which is 7 also. So, 7 minus 7 is 0. So, it's here, P of 1 is 0. So, the remainder is 0 using the remainder theorem. Let's try checking on synthetic division. So, for the synthetic division, we're going to place 1 here on the left corner, and then we're going to get the coefficient, which is 4, negative 2, 3, negative 5. So, we bring down 4. 4 times 1, which is 4. Negative 2 plus 4 is positive 2. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 5 plus 5 is 0. So, it's here, the remainder is 0. So, using the remainder theorem, we have 0. And same with using the synthetic division, the remainder is 0. Let us try to work on with this activity, which will require us to apply the remainder theorem to solve more challenging problems. So, let us find the remainder. If 7 times x raised to 451 minus 3 is to be divided by x plus 1 and x minus 1. So, let us have a brief recap that if negative 1 is raised to even number, the result would be positive 1. But if negative 1 is raised to odd number, the result would be negative 1. So, let us try evaluating our x plus 1. So, for x plus 1, it means that we are calculating here p of negative 1 and substitute it to 7x raised to 451 minus 3. So, p of negative 1 then, 1 will be substituted to 7 times negative 1 raised to 451 minus 3. So, let us simplify what is negative 1 raised to 451. 451 is an odd number, that's why it is negative 1. Bring down negative 3. So, negative 7 times negative 1 is negative 7 minus 3. That is why the remainder here, p of negative 1 is equal to negative 10. Let's try answering B, which is B, x minus 1. So, if our divisor is x minus 1, it means that we will be calculating p of 1 and substitute it to the equation 7x raised to 451 minus 3. So, that we have 7 times 1 raised to 451 minus 3. So, we have 7. 1 raised to 451 is still 1 minus 3. So, 7 times 1 is 7 minus 3. That is why the value of P of 1 or the remainder here is positive 4. So that's it. Let's try to work on with more examples. Use the remainder theorem to find the remainder when the polynomial x cubed minus 4x squared plus x plus 6 is to be divided by a, x minus 1, b, x plus 1, and letter c, x plus 2. So for letter A, x minus 1, it means that we are going to calculate P of 1. Substituting the value of P of 1 into the equation, we have 1 cubed minus 4 times 1 squared plus 1 plus 6. Simplifying, we have 1 minus 4 plus 1 plus 6. That is why the value of P of 1 or the remainder is 4. For letter B, we have x plus 1. It means that we are going to calculate for P of negative 1. Substituting the value of negative 1 into the equation, we have negative 1 cubed minus 4 times negative 1 squared plus negative 1 plus 6. Simplifying, we have negative 1 minus 4 minus 1 plus 6. That is why P of negative 1 is 0. It means that the remainder is 0 if the divisor is x plus 1. So for letter C, we have x plus 2. It means that we are going to calculate for P of negative 2. Substituting all the values of negative 2 into the equation, we have negative 2 raised to 3 minus 4 times negative 2 raised to 2 plus negative 2 plus 6. Simplifying, we have negative 8 minus 16 minus 2 plus 6. That is why the value of P of negative 1 is equal to negative 20. It means that the remainder is negative 20 if the divisor is x plus 2. Let us try more challenging examples using remainder theorem when 6x raised to 456 plus 2 is divided by a, x plus 1, b, x minus 1. For letter A, it means that we are going to calculate for P of negative 1. Substituting the value of negative 1 into the equation, we have 6 times negative 1 raised to 456 plus 2. Simplifying, we have 6 times 1 plus 2. 6 plus 2, we have 8. So it means that if the divisor is x plus 1, the remainder is 8. For letter B, x minus 1, it means that we are going to calculate for P of 1. Substituting the value of 1 into the equation, we have 6 times 1 raised to 456 plus 2. Simplifying, we have 6 times 1 plus 2. And then 6 times 1 is 6 plus 2. That is why P of 1 is 8. It means that the remainder is 8 if the divisor is x minus 1. Until our next session, thank you and enjoy learning.